Hello, everybody. Welcome to week 11T. I don't know of distance e-learning, emergency learning, whatever we're calling it. I hope you had another wonderful weekend. Today is actually Thursday, April 16th. So I'm recording obviously before you're hearing this. So I hope you had a good weekend and I hope the weather has been better on the weekend than it is today. It's quite cold, but sunny. So I hope you're doing well. We're getting through. So today we are going back. In cycle 1, we did a little bit on the exponential function. And we're going to go back today and review a little bit and add a little tiny thing new at the end. So the learning goal today is to be able to identify exponential functions and represent exponential functions with a table of values, with an equation, and with a graph. Okay. And I'm going to be trying something new today when I'm filling things in. So it might be a little slow. So we'll see how it goes today. So let's do a little bit of review. Take a look at these exponential functions. Remember, exponential functions are different than any other function you've seen because the x is the exponent. It's not in the base of a function. It's actually the exponent. So if we have these 5 different exponential functions, well, which of these represents exponential growth? So which curves are going to go up? Which one of those would have the fastest growth? Which represents decay? So which graphs are going to go down? And which would have the fastest decay? So what I've done is I've actually gone ahead and graphed these in Desmos. So I'm going to show you them right now. So if we go to Desmos, here they all are. So 5x, 5 to the x is the red, blue is 7.2, the purple is 3.2, the blue is 0.42, was that the other one? And the green is 0.57. So you notice these that are going up, because remember we always read graphs from the left to the right. Those that are going up, those are growth. So which ones are those? So that's the blue one, the red one, and the purple one. And what do you notice about all those numbers? They are bigger than 1. So there's the answers right there for you. So which represent exponential growth? Well, the ones with the base that have a number bigger than 1. And if we look at those graphs, which one's the steepest? Well, you notice the blue one is going up faster and faster, right? It gets to 5 before the purple one gets to 5, right? So the bigger the number, the steeper it is. And if you look at the other two, the ones that are decay, those are numbers between 0 and 1. So they're decimal numbers or they're fractions. And notice, in this case, the smaller number has a faster decrease, okay, or a steeper graph. So if we're looking at decay, the smaller the number, the faster it's going to decrease. So let's go back to here so you can get those answers again. If you want, while we're doing this, you can either write it down in a notebook or just be going through it on your own with your PowerPoint slides going as well. So again, exponential growth are those with the base, so the number is bigger than 1. And the fastest growth is the one that has the biggest number. And decay are the ones that are between 0 and 1. So it's a decimal or it's a fraction. And the fastest decay is the one that's the smallest of the two. And so that would be 0.42. So we did that last cycle, but I know it's been a very long time since that, so that's why we're going over it again. So let's take a look at the exponential function, the key ideas. So the exponential function looks like this. F of x, or remember this used to be y, so you could put y, like we had on the last slide, equals a times b to the x. And I'm going to talk about this a little bit later. Right now we're going to think about when a is 1. So it would just be b to the x. So if b is greater than 1, we have exponential growth. It doesn't matter what a is. If there's a number here, anytime b is greater than 1, you're going to have an exponential growth. Okay? And the greater the value of b, so the bigger the b, the faster it will grow. So here's an example. Here's 3 examples. And I'm writing the equations here for you. So notice how we've got y equals 2 to the x, 3 to the x, and 6 to the x. And the bigger the number, the steeper the graph. Notice how they all go through 0 and 1. And that happens when a is 1, or when we don't have an a in front. Okay, later on in a couple slides here, we'll go through what happens when we do have a different value for a. So that is exponential growth, okay? Now, for decay, and that happens when b is between 0 and 1, so a decimal or a fraction, okay? And the smaller the value of b, the faster it will decay. So let's show an example here. Here are 3 examples. The red one's 0.8 to the x, blue is 0.5 to the x, and the green is 0.2. So notice how as this value, the b, gets smaller, the graph gets steeper. Okay, it's going to decay faster. And again, they all go through y equals 1. And that's when a is 1. Okay? So those are key ideas. Some common characteristics of these graphs, when a is equal to 1, they always cross the y-axis at the point 0, 1, or when y is 1. Okay? The domain is all real numbers, right? If we go back to those graphs, notice it's going to go forever in the negative x direction and forever in the positive x direction. And how do we write that? Well, remember, D for domain, curly bracket, X. You can put whatever E you want here. Sometimes I put a little e so I don't have to go searching for that special E. X is the element of the real numbers, and then close brackets. Now for the range, it's all positive real numbers. So it looks like this, right? And that's because they have an asymptote, the x-axis. So an asymptote is the line that they get really, really close to, but doesn't actually touch. So if we go back to those graphs, I'm just going to go back here. Notice how they're getting really, really, really close to this x-axis, but they don't actually touch the line. Okay, I know it looks like it does, but it does. If you zoomed in, you would see it would never touch the line. So that's why the range is greater than 0. It doesn't equal to 0, but it's greater than 0. And so we write it like that. Okay, let's take a look when our a in front is not 1. So this time we have 3 times 2 to the power of x. So to do this, we are going to make a table of values. And this might take a while because I'm actually going to type it in as we go. Okay, so, and then I'll show it at the end. So remember, y here is equal to 3 . Oops. What am I doing? Let's not cut it, Alyssa. Ms. Gilbert, sorry. I talked to myself. So y equals 3 times 2 to the x. And to make my little x, I'm going to go superscript. So now, every time we have a new x, we have to replace the x with that value. So this is going to be 3 times 2 to the negative 2. Okay. And then if we put that into our calculator, 2 to the negative 2, remember that's 1 over 2 squared. So 2 to the negative 2 is a quarter, or 0.25, times 3 is 0.75. I'm going to make this bigger. Okay, so now we're going to do that for the rest of these guys. So this one, instead of being 2 to the negative 2, we're going to put in our x as negative 1. And so if you do 2 to the negative 1, that's 0.5. And then times by 3 is 1.5. And now this is going to be the same thing, but it's going to be 0 now, isn't it? So remember, anything to the 0 power is 1. So 3 times 1 is 3. Now you should start seeing a pattern here in our ratio, but we're going to finish this off. So 3 times 2 to the 1. 2 to the 1 is just 2, so 3 times 2 is 6. And now we're going to do 3 times 2 to the 2 equals 2 to the 2 is 2 squared, which is 4. 4 times 3 is 12. And finally, 3 times 2 to the 3. 2 to the 3 is 2 times 2 times 2 is 8 times 3 is 24. Now, notice your ratio here. Remember when we do our ratio, we do the bottom one divided by the top one, right? So if I do a scribble here, let's do it in red so you can see what I'm doing. Why can't I see anything? Scribble. Oh, okay, there we go. Sorry guys, I want to do this quickly. Okay, I'm just gonna go to text. Okay. So 1.5 divided by 7.5, so 1.5 divided by, 0.75 equals 2, right? Oops, that should be 0.75. I'm going to make this guy bigger too, eventually. Okay. And so for the ratio here, you're going to do 3 divided by 1.5. Arg. Equals to 2. Notice how all of our ratios are 2, right? 6 divided by 3 is equal to 2. 12 divided by 6 is equal to 2. And 24 divided by 12 is equal to 2. So remember, our ratio should be the same as our b. That's awesome. So now let's plot this. I think I'm going to use a shape for that. We'll use a little circle. Okay, so negative 2, it's at 0.75. So negative 2, it's kind of almost here, right? Did that do anything? No. This is why I really wanted to make sure I could do this, right? Okay, let's just put it here. Okay, close enough. I'm gonna make it a different color. How do I do that though? Sorry guys, I'm really trying. I really wanted to do this. Okay, so this is hilarious. Okay. So -1, it's at, oh, and I did that on the wrong side, didn't I? Hope you guys were watching that. Okay. I'm really trying here. Scribble. Okay, at -2, it's at 0.75. Scribble. So it'll be up here, right? And at -1, it's at 1.5. So that'll be like here. And at 0, it's at 2. Nope, that just moved that. That's okay. 0, it's at 2. Okay. 1, it's at 6. And that's going 1, 2, 3, 4, 5, like up here somewhere. So you can see that we're getting our line, right? So if I do scribble again, we're gonna put in like to go through our points. I know it's not perfect, guys, but I'll put a nice graph for it. Okay, so if we look at our y-intercept, our y-intercept is where it goes through the y-axis, which was 3. Oops, I put 2, didn't I? Okay, anyway, it's 3. I'm going to put in a nicer graph. How about that? So our y-intercept is 3, and I'm going to change this to red so you can see it. Our b is 2. You get that right out of the equation. Our a is 3. Is it increasing or decreasing? Well, you can tell from my really, really terrible graph that it is going up. So we're going to put a circle around that guy, that it's increasing. And I'm just going to not fill it and put red around it. The domain, well, just like everything else, the domain is x is the element of the real numbers, because it's going to go forever to this way and forever that way. And the range is, it's getting closer and closer to the x-axis. So y is the element of the real numbers such that y is greater than 0. Okay. Erase some of these. Okay, so those are our answers, and I'm gonna put in a nicer graph later on so that it'll be in the slides when you go through it. Okay, so let's take a look. That happened. This is what happens when we have a is not 1. Notice the connection here between a and your y-intercept. So a is actually going to tell us our y-intercept, which is really nice. So let's go here. I don't know if I want to look at this. Oh, that's hilarious. I hope you guys did a better job, or at least followed me. Okay, so if we look at our equation, I'm going to start giving you some different terms because then it makes a little more sense. So what we have on the left side, if it's f of x or if it's y, that's what's called our future value. That's what we're looking for. What is it going to be in the future if we use these other numbers? So a tells us our starting value. That's where it goes through the y-axis. B tells us how it changes with each step of x. And x tells us how many times we change it. Okay, and that's going to come into play when we talk about compound interest and other applications, okay? Now, I just wanted to show you something quickly to go from a table of values to get the equation. So what I want you to do here is look at 2 things. The first one is, because remember, I'm going to go down the next slide so that it's the same. So remember the equation is y or f of x equals ab to the x, right? So, and I'm going to put this, everything I do on this slide, I'll put in red so that you know what's new. So when we determine the equation from the data, remember A was where the line intersected the y-axis, and that happens when x is 0. So when we find A from the y-intercept, So I'm just going to do this in red, and that's when x equals 0. So in that case, our A, because our y-intercept is 2, our A must also be 2. So A equals to 2. And then you can find B from the ratio of y values. So remember, you're always going to do the bottom one divided by the one above it. So 6 divided by 2 is 3. And if you check it, if you do 18 divided by 6, that's also 3. So B is equal to 3. Okay? I'll put that on right. So that means our equation, so therefore, equation is y equals, our A is 2, our B is 3 to the x. Okay. I'm going to underline that maybe. Okay, verify this equation by substituting x equals 1. Okay, so if we have y equals 2 times 3 to the x, I can't tell if this is better for me to do it on paper with you guys or for to do it on here. At least you're seeing my thinking. So if you have 2 times 3 to the 1, so 3 to the 1 is 3, 2 times 3 is 6. So that matches. Okay, so now we're going to try that again with x is 3. Actually, I'm just going to copy this whole thing to make it easier on myself. So if we now have 3 to the 3, so 3 to the 3 is 3 times 3 times 3 is 27, and 27 times 2 is equal to 54. So that checks out. Okay, good. So that means we have the right equation. Okay, so that's the lesson. I hope that wasn't the best, guys, but I hope you get a handle on it. If you need to rewatch it, please do. If you have any questions, let me know. Please go to the envelope in Brightspace, and you can instant message me or send me an email. So you try. I'm going to post some practice questions. Okay, it's going to be called 2.11 Exponential Functions Practice. I will post my solutions to that so you can check your solutions. And then once you feel comfortable with that, you can complete the 2.11 quiz on Brightspace. So if you go to homepage in Brightspace and you go to quizzes, and I'll post this as well. But if you go to quizzes, you'll scroll down to 2.11 quiz. And I think there's 4 questions or something like that. Okay. So that's it for today. I will put in a nicer graph of this later on the next slide so you can see it better. Otherwise, please let me know if you have questions, and please stay well. We'll talk to you guys later. Bye-bye.